Okay, so for division, we can find the remainder. When this number is divided by that number, what is the remainder? What is the quotient? And so we have sometime we have those kind of problem from remainders find divided. Okay, so let's say like so there's a problem. This number divided by 3, remainder is 2. This number divided by 5, remainder is 3. So what is this n? So we have many source n, many such numbers. So if we just find one of them, we can do this. Let's say n divided by 3, remainder is 2. We can list all source numbers. First number is 5, right? 5, then plus 3, 8, okay, and plus 3, 11, right? Just plus 3, plus 3, plus 3, 14, plus 3, 17. So those number divided by 3, remainder is 2, right? And then those number divided by 5, remainder is 3. So first number divided by 5, remainder is 3. First number is 8. Second number just plus 5, right? Plus 5, 13, plus 5, 18, plus 5, right? Plus 5, 5, 18, then plus 5, 23, like those numbers. So what is this number n? So this number is let's just say 5, 28, like. Okay, so those numbers are common number. So we find a satisfy both of them. So we say n equal 8. 8 divided by 3, remainder 2, yeah. 8 divided by 5, remainder 3, yeah. Okay. Okay, so if we want to find a general form for n, so we should write this: n divided by 3, remainder 2, n equal 3k plus 2, right? And n divided by 5, remainder is 3, so n is also can written as 5. 5, so maybe put a k1, here put a k2, right? k2 plus 3. So we want to find the form for n, the general form. So the idea is we can, so that here same story. We put a k2, we got it k2 in terms of 3, let's say 3n plus r. So here r, so divided by 3, so remainder could be 0, 1, 2. So we just check which r satisfy both condition. So we just plug in second one, n equal, so we put it to here, n equal 5k, 5k2, the k2 is 3n plus r. Okay, so plus 3. So n equals this 5k2 plus 3. So this one equal 15n plus 5r plus 3. So this divided by 3, remainder is 2. So we can find what is n. So n equals 0, not work, right? N equal 1, n equal 1 is okay, right? Divided by 3, divided by 3 remainder 2, so n equal 1 is okay. So you find r equal 1 is okay, so we just pick r equal 1. So we find this number should be equal, n should equal 15 n plus 8. Okay, so when n equals 0, this number is 8. So n equal 1, this number 23. Okay. Okay. So for this problem, this number divided by 3, remainder is 2. This number divided by 3, remainder is also 2. So here, this remained the same. So we know n can be written in this form. Oh, no. Divided by 3. So, I'm sorry. Should equal n equal, if divided by 3, divided by 5, remaining 0, then the 15k. Yeah. So this is 15k plus 2. Okay. So here we have this conclusion. We say if the remainder is same, like n divided by a, remainder is r, n divided by b, remainder is also r, then n, this number can be written as k, abk, k times ab plus r. Okay. So for this problem, let's say, this divided by 3, remaining 2. This divided by 5, remaining is also 2. What is the remainder when this divided by 15? So remainder is also 2. Okay. Okay. Same for this problem easy. Like n divided by 4, remainder 2, divided by 5, remaining is also 2. So this n can be written as 20k plus 2. So what is smallest n? So the smallest k could be 0. 0 not okay, not work, right? 0. So 0 is 2 divided by 4, remaining is 4. This make maybe no more sense. So we just pick k equal 1. So this n equal 22. 22 divided by 4, remainder 2. 22 divided by 5, remainder is also 2, right? Okay. So here we have a whole number larger than 2. This number leaves a remainder of 2 when divided by 3, divided by 4, divided by 5, divided by 6. So what is smallest such number? Okay, so maybe you can say this n should be 3 times 4 times 5 times 6k plus 2. But this is not okay because here if we multiply 3 multiply 4, then we don't need to multiply 6. Okay, so this number actually should be 3 times 4 times 5, then k plus 2. So this equal 60k plus 2. So the smallest number, we just pick k as 1, right? So smallest number is 62. Okay. So this number is between this is 60 to 79, right? Okay, so this number quite the same as the previous one. We want to find the smallest positive integer that leave remainder of 1 when it is divided by 4, 5, 6. So again, so we say this number can be written as 4 times 5 times 6 k plus 1. But here we don't need to multiply this 4, 5, and 6 because so here actually we just need to multiply 4, 5, 3 will be enough, right? Oh, why divided by 3 enough because we already multiplied 2 here. So from here we can say like we just pick those high large exponent. Here we have 2, so here we don't need to multiply 2, 1. But anyway, here so we know this equal 60. We just choose 60k plus 1. Okay, so k. K, we just pick k equal 1. So here we want to find how many integers between 1000 to 2000 have all 3 of those numbers as a fact. Okay, so here the key point is those numbers. So we say equal 15 times 20 times 25 k, right? But we say we don't need multiply the 25, so we maybe so here 15 is 3 times 5, 20 4 times 5, 2 times 5 times, okay, 25, 5 square. So here maybe we don't need, it's not necessary to multiply that. Then we just pick for these 3 numbers. We just pick okay, for 5 we just pick 5, 2. Okay, and here we just pick 2, 2, and 3, 1. We just need to multiply this. Okay, so this equal, let's say 12 multiply 25. Okay, 12 multiply 25 is, let's say 4 multiply 25 is 100, 300, right? 300k. Okay, so how many k we can pick? So smallest k should equal 4, right? 4, 5, 6, 7. Oh no, not 7. So we have only 3 possible k value. Okay. So this problem says we have a number n. So n is a 2-digit number. So this number divided by 9, remainder is 1. Divided by 10, remainder is 3. So what is this n divided by 11? So here we need to find this number. So to find this n, we have 2 ways. One way, traditional way, is if n divided by 9, remainder is 1, so we can write n in this form. N equal 9 k plus 1. So n is divided by 10, remainder 3. So we can write this in this form. So we just try find which k or n satisfy both of them. So we can use this way. Like we let this k in terms of 10, like divided by 10, we can write k equal 10m plus r. So then r can be have those 10 numbers. So plug in here. So we have this n equals this number. So we then go back to check here. Divided by 10, remainder is 3. So this, let's say 9r plus 1. This divided by, oh, I'm sorry, divided by 10, remainder is 3. So we just check which r satisfies us. So r equals 0, r equal 1 is okay, r equals 3 is okay, or 2 is okay, 3 is okay. We just pick. So here we have this question, too many r. So here too many, we have 10 possible r value. So we need to check 10 of them. So maybe this is just take some time. So for this problem, so other way is because this is only 2-digit number, so we can list all those numbers. Let's say based on this, n is n divided by 9, remainder is 9. So we can list those numbers divided by 9, remainder 1. 10, then plus 9, plus 9, plus 9, right? So we have this. So n divided by 10, remainder is 3. So divided by 10, remainder is 3. So 13. So plus here plus 10, right? So 23, 43, 53, 63, 73, 83, 93. Okay, so we just check. Oh, we find this number satisfy both of them. So n is just this number, right? Okay, so then this number divided by 11. What is the remainder? So this by now, this problem become very easy. Okay, so here we talking about we find this number from the information for remainder. Okay, then we have also have those numbers like we want to find the dividend from quotients. So let's check this example. Like suppose we know this number is 100. So we know 100 divided by 5, quotient is 20, right? And if this number 100 divided by 3, quotient is 33. So now from the quotients, we want to find this number n. We want to find n. Okay, so now we have such a problem. We want to find this n such that when it is divided by 3 and divided by 5, the difference of quotients is, we do not tell you are 20 or 33. We just say that difference is 13. So how can find this n? Okay, so let's say, okay, so we say Q2, we only know Q2 minus Q1 equals 13. Okay, so we do not consider the remained. So we say, so divided by, so here, this divided by 3, quotient is Q1. So N should equal 3Q. Let's say which one is Q2? Big one is Q2, divided by 3. So this should be 3Q2 plus some remained. And this N divided by 5, quotient is 20. So this should be equal 5 times Q1 and plus remained. So here those two remained not the same, so we should put R2 and R1. So here R2, so this R2 is this N divided by 3. So the R2 can be 0, 1, 2. Then R1 is we talking about this number divided by 5. Divided by 5, so quotient is Q1. Okay, so then R1 can be 0, 1, 2, 3, 4. Okay, so the information we have is just this: Q2 minus Q1 equals 13. So we can replace this Q2 as we just Q2 equal Q1 plus 13. Okay, so we just plug it in. Okay, so we have this like 3 Q2 Q1 plus 13 plus R2 equal 5 Q1 plus R1. So this is N, and so we also have this equation. So we have this equation about so we move Q1 here, so 2Q1 equal, so move those constant. This is 39 plus R2 minus R1 equals this. Okay, so we have this condition. Okay. Okay. So we don't know Q1, we don't know R2, R1, but only we have this. So let's say, so here we say 39 plus this number should be 2 times this. So this number R2 minus R1 should be an even number, right? Should be an even number. So should be equal 2 times some k. It's an even number. Okay, so then we just check all this from here. So we just check R2, R1. So from here we check which case R2 minus R1 is even number. So this even number could be positive even, could be negative even, right? Okay, so at the first we say we can R1, R2 can be thus. R2, R1 could be 0, 0, 0, or could be 1, 1, could be 1, 1. Oh, could it be 2, 2? Could it be 3, 3? No 3, 3, right? This is like k equals 0, or R2, R1. Could it be, let's say, could it be like a 2, 0? R2 equal 2, yeah, could it be 2, 0? Or could it be negative 2? Negative 2 is R2 is 0 and 2, right? Could it be 2? K equals 0, K equal 1. R2 minus R1 could be 1. Could it be 2 and negative 2? Or could it be 4? So R2, R1 could it be 4? We say only this case. R2 is 0, R1 is 4. Okay. So we have many cases. So we just check like let's say, so we check one by one whether this let's say if we check this case, is this okay? Like R2, R1 equals 0, 0 equal. Oh no! I made a mistake. Cannot be. Oh, I made a mistake here. Cannot be. Should be odd number. Yeah. So I made a mistake. Okay. So let's say. So I did the same. So it's not okay. So let's say. So we have many cases. Just let's say. So if this equal 1 or negative 1, so if this equal 1, we say 1, how about 1, 0? If this equal 1, 0, then we find, so Q1 equal what? So from here we can go back to here. If R2, R1 equal 1, 0, then Q1 equal 20, right? Q1 equal 20. So we can put so then from here we can find Rn equal 5 times 20 plus R1. R1 is 0. So we get this number N equal 100. Okay. Okay. So let's check some other. Let's say, so if this R2, R1 equal, let's say, how about R2 equals 0, like equal negative 1. So R2 equals 0, R1 equal 1. So R2 minus R1 equal 1, right? So this is also okay. So in this case, we find Q1 equal what? Q1 1 0. Q1 is also 20, right? Q1 equal 20, then N equal 5 Q1 plus R1. N equal 5 Q1 plus R1. So R1 equal 1. So N equal 101 also satisfies the condition. Okay. So we have, let's say, we have many several n's. Like 100 is one of them. Like this number divided by 5, and divided by 3, and divided by 5. The difference of quotient is 13. So we have several such numbers. So sometimes we need to find all of them. So we just check one by one. So such a problem could be a little bit tough. So here actually we have such a problem in the AMC. It says like you have a cat and a dog. Okay. So you have a stair. Okay. At your home. So so let me see. We don't know how many steps in steps. So the cat always jump 2 steps, except the last one. So the dog always jump 5 steps, except the last one. So for example, if n equal 21, if we have 21 stairs, so the cat will jump 11 jumps, right? And the dog, by why 11? Just a 10 plus 1, right? So dog will jump 5, 4 times 5 is 20. Then they still have 1 steps. So the dog need 1 more. So 5. Okay. So we let C be the number of jumps of a cat, and D be the number of the jump of dog. So we know this. Then we want to find A. So we say we have many n's. So the question is find the sum of all of such a. Okay. So now let's check this problem. Okay. So if let's say like here, if cat jump 11 times, so say the 14 times, like 14, each jump is 2 steps, right? So last jump could be 1. Could be last jump. Could be 1, could be 2. Okay. There. So we write this n equal 2 times c minus 1 plus r. So this r can be 1 plus or 2. So let's say if n equal 20, then cat just jump 10, right? So previous 9 jumps, each one is 2. Then last one is also 2. So if 21, so last one is 1. Okay. So for dog, so we also can write this like n equal 5 times d minus 1. So the first d minus 1 jumps, each one is 5. So plus last one. So here last one could be 1, could be 2, could be okay, like this, right? So we want to find n. Yeah. Okay. So the relationship is C. So we say C. So we changing the C equal D plus 19. So we just replace C by D plus 19. So n equal 2. So here the D plus become 18, right? So plus R1. And also n equal 5d minus 5 plus R2. Okay, so we need to solve it. So this, so n is equal, so we say we get this. So equation 2 minus equation 1, so 3d minus 5 plus R2, so minus so 6 minus R1 equals 0. Okay. Okay, so we say, so 3D equal, let's say, 41 plus R1 minus R2. Okay, so this number is a multiple of 3. So we find so this R1 minus R2 should be those numbers. 41 so should it be like a 41 plus, could it be 2, right? This number could it be 2? Oh no, could it be 1? 42, right? 42 so can be, let's say 41 divided by 3. We just change this number or the small divided by 3. What is the remainder? We just check the remainder. Yeah. Remainder 2. So we can check like, so we have this. So 2 plus R1 minus R2. This, we can say this divided by 3 is 0. So we also can use this notation. We say module 3 divided by 3, remainder is 0. Okay. So if this remainder is 3, so we can say this number can be 1, or can be negative 2, right? And also this number can be, let's say 1, 2, can be 4. So can be 4, or can be, let's say, so can be 2 plus 1, 2 plus 2 minus 2, 2 plus 4, and 2 minus 4. No, so it seems like, let's say, so what could it be? R1, R2. So R1 can be from 1 to 5. R2 can be from 1 to. So this R, oh, here's R2, I'm sorry, R2. Okay, so these numbers R1 minus R2, R1 minus R2, could it be 0? But there's not. Could it be, no, could it be 1, could it be 2, could it be 4? R1 minus R2. So we R1 minus R2. R1 minus R2. Yeah, could it be negative 4? 2, could it be 4? R1 minus R2. Not positive, could it be negative 4? Yeah, negative 4. 2 minus 4. 2, oh, negative 4 maybe not work. Okay. Plus 1 plus okay, can be So here we just focus on this. Let's just say, okay. So it seems like R1 minus R2 can only be, there's two possible numbers. Could be 1 or 2. So let's check when R1 minus R2 can be 1. So let's check like, so let's say again with just R1 could be 1, 2. R2 could be 1, 2, 3, 4, 5. Okay, so R1 minus R2, so which one can be this? So we say R1, R2 could be 2, 1 is okay, right? 2, 1. 2, 1. So only one solution, right? 2, 1. 1. How about 1, 1, 5? 4. Okay, it seems like we have only. So now suppose we have this. If the R1, R2 is this, then we can go back. Then we can find A. So if R1, R2 equal to 1, then we can find that from here we can find D or 3D equal 41 plus 1, 42. Okay, so then we can find D equal 12, right? So D equal 12, then we can find what is N. So N equal 5D. Let's say N equal 5D minus 5 plus R2. 5D minus 5 plus R2. So equal 5 times 12 minus 5 plus R2. R2 is 1. So this equal 60 minus 4. Okay, so we find this equal. So this is one solution. Yeah. So we say in one solution thus. So we can check other case in 2, maybe in 3. So here the tough one is like from this equation. We need to find a solution. So we just find what the R1, R2 can be. So R1, R2 just those we can choose from those numbers. So we say R1 minus R2 can be only like 2, 1, right? Okay. So let's say that we also can check how about this equal negative 2. So if this equal negative 2, R1 minus R2 equal negative 2. So could it be like could it be 1, 3, this negative 2, right? Also could it be 2, 4, negative 2, right? Okay. So this such a problem is a little bit tough. So here so we need, because we need to check this case, that case, right? Okay, but the idea, I hope you can understand. Okay, so we can stop here.